All right. So, throughout this chapter, you are going to have to know basically what is the deal with fractions, and it totally depends on which one you're supposed to be dividing by. For example, on this first one, I tried to have the computer work a little bit better with me here. It didn't really seem to want to. But what it's really saying is take 1/2 and divide it by 2. You see how if you can kind of make that second one a little bit bigger, it's easier to see. Because right now, what some people would try and do is they would say, hey, that's 2 divided by 2. That's just 1, so it's 1 over 1, so the answer is 1. Well, not if you're actually taking 1/2 and dividing it by 2. What you want to do is whichever one is you're actually dividing by, you want to kind of multiply by the reciprocal, because we know dividing by 2 is the exact same as multiplying by 1/2. And what some people like to do is they say, okay, well, there's my fraction that I know is on top of 1/2, and we're dividing by 2, and some people like to do that. And so then they can flip it as it works its way up. As it goes up, they will flip it. But I think most of us know that dividing by 2 is the same as multiplying by 1/2. So now this one is gone, and so the actual answer here is 1 times 1, which is 1. 2 times 2 is 4. Okay? Because when you're multiplying, you multiply straight across. This is not cross-multiplying because it's not two fractions equal to each other. Okay, it's just straight across. So same thing here. It probably would have worked out better had it been 2/3 divided by 3. Again, I think we know that dividing by 3 is the same as multiplying by 1/3. Or again, some people like to do that, and then they flip it up, working its way up there, so then it's gone. And then you can go ahead and multiply. So the numerator is 2, and the denominator is 9. Very good. I want to see if somebody was going to say 6. But 3 times 3, so it's 2 9s there, 1/4 there. Nope. You can't. Now, we're going to simplify each one of these as well. Simplifying with trig, I'm pretty lenient a lot of times. What I tell a lot of people is I think most of us are more comfortable with sines and cosines. You start getting secants or cotangents or even tangents, and things get a little bit iffy. But I look at it this way then, that this is really saying take cosine and divide it by, well, how can we rewrite tangent so that it's just sines and cosines? It is sine over cosine, correct? Because that's what tangent is. I just rewrote it right here because that's what tangent is. Okay? But do you see how cosine is really the one that's on top right now? Do you see that? Does that make sense to everybody? So what we really need to do here is, because it is cosine divided by sine. So you notice how I tried to make that one a little bit bigger? So what we're really saying is that we're going to not divide by sine over cosine, but we're going to multiply by cosine over sine. So really what I have is that cosine that was on top times, and we got to flip this one, cosine over sine, correct? So what can I put in this location here on the bottom left so that it makes sense? Yeah, a 1. But do you see how it would be very easy to mess this one up? It'd be very simple to do that. And so what we really have here is we have cosine squared of x on top, because that's what cosine times cosine is, right? Over sine of x. I'm good with that. As far as simplifying goes, let's try and get to sines and cosines to the best of our ability. Yes? Right, if you want to, you could say this is cosine of x times cotangent of x. Again, to keep it so that we all simplify the same way, let's go for sines and cosines.
Excuse the interruption. Isabella Friday to the middle school computer lab, please. Isabella Friday to the middle school computer lab.
Yes, the question is, can you write it this way? Can you write the problem or the answer, say, this way? Yeah. Yeah, that's fine. Yep. It's how, you know what? However you want to write cosine or sine to any power, that is completely your choice. I'll accept either way. Again, remember, this works for any power. 15th power, either way works. Okay. So then, well, what's the deal with this one then? Well, if we're going to go for sines and cosines, tangent is sine over cosine, which I'm trying to divide by cosine. Now, this might be a weird one. Let's listen to this and see if you agree. Dividing by cosine is the same as multiplying by secant. Is that really true? It is. But again, I'm telling you to stay with sines and cosines, right? So if I've got sine over cosine, I'm dividing by cosine. Some people kind of like to do that, right? Because again, here's that main division bar. And so you got to kind of look at it as a top and a bottom. And this one, what's going to happen to it? It's going to flip. And so for those of you that didn't see the secant earlier, there it is right there, 1 over cosine. Okay. So this one's gone. So this one turns into sine of x over cosine squared. Yep, ends up being pretty much the opposite. Now, the reason I say I'm pretty lenient with simplifying is some of you might want to just say secant of x, or sine of x times, tangent of x times secant of x. And that's actually true in this problem. But let's all do it the same. Let's all go for sines and cosines, because I think it's going to help you later. Okay. So that, I guess, you can look at as that's the deal with fractions. Okay. You got to know kind of which one are you actually trying to divide by. Okay. Simplify. Well, I know it's definitely not solved because what's not in this problem? There's no equal sign. So we're just trying to get this to look as, I guess, easy as we can. So I look at it as though we have two terms. We have secant squared right there, and then we have secant squared tangent squared right there. Whenever, and I chose this one on purpose, whenever you have the same thing in all your terms, for example, you may have had something like this before. We would factor out that x squared, right? And then we have 1 plus y. Do you remember doing that in Algebra 2, something like that? Do you agree that both terms had an xy, but I couldn't actually add them together? So right here, do these both have a sine squared, and I can't actually add them together? So let's factor out the thing they have in common, which is sine squared. But then you have to make sure that you don't mess up that parentheses. Because over here on this one on the right, if I didn't write that 1 down right there, would this have been correct? No, because then when I multiplied it back out, it wouldn't have worked, right? So what happens here then with trig? It works very similar. What should I write down first in the parentheses? A 1, yes, plus tangent squared of x. Now, see, this is the first day you've seen any of this simplifying stuff, so I don't expect you to be experts by any means. But I did give you one very important suggestion yesterday, and that was whenever you see a trig function squared and a 1, where are you supposed to look? Look at your Pythagorean identity, so get out yesterday's notes, and let's see, do we have one of them that has tangent squared and a 1 in it?
Yes.
Okay, so what does it say? What does it actually say that identity says equals secant squared? So you're telling me that right there is exactly what that identity said. Now remember, can we kind of manipulate these identities if we need to? You know, do algebra like add, subtract 1 to both sides or do stuff like that? We can, but we actually don't have to. So you looked at your other sheet of notes, and what this means is tangent squared plus 1 the same as 1 plus tangent squared? Yeah, because addition is commutative. And so this right here, I'm going to completely replace. That's what I would do. What would you completely replace? Yeah, this is, here it is right here. It says tangent squared plus 1 automatically will equal secant squared, and that's every time. Not just this time, not just a couple times. Anytime you have a 1 plus tangent squared and you want to replace it, you can replace it with secant squared. So that sounds like a pretty good idea to me. So it's sine squared x times secant squared x. Do you agree with that? That's looking pretty good. You know what? To be honest with you, I'd be pretty happy with that. If you got that far, I'd be really happy. If you got to the next step, I would be extremely happy. Because in simplifying, I told you to get to sines and cosines, right? Let's see if that helps. Well, is this already in sines or cosines? Yeah, so there's nothing there. How can I write secant squared? Close. Cosine squared. If it's secant squared, it's 1. What if it was secant to the 5th? It'd be 1 over cosine to the 5th, okay? Or if it was, say, tangent squared, it'd be sine squared over cosine squared. Okay? So this is really over. So in other words, if I multiply my tops, I get sine squared over cosine squared. Tangent squared. Now, This one worked out really nice. Believe it or not, all of this right here is saying the exact same thing as tangent squared. Which one would you rather deal with? This big circled one up there or tangent squared? Okay. Now, am I okay if you got this far? I'm very pleased if you got, this is the first day you've started doing this stuff. I'm extremely happy. All right? But I just kept showing you what things to look for. Yes, Mom. I would accept this. I'll be honest with you. The question was, what answer do you want us to put? This particular chapter is a pain for me to correct because I correct your work. I go through and look at what you were thinking. So it takes me forever to get stuff corrected, but yeah. At the beginning, you can't cancel out the signs because it would be like dividing everything by sign, but we don't have an equal sign in there. So we don't have something else to divide by sign to keep it balanced. So you can't really do that. Okay?
So that other one you have circled in green, that could be
The one in green would be a spectacular answer.
I mean the red one.
Oh, the red one I have circled? Yeah, that'd be fine. Now, what if I were to do this? This problem's done. What if that square wasn't on the cosine? Does that still become tangent squared? There's no square on the cosine. Does this still become tangent squared? Nope, they both got to be squared. Sine squared over cosine squared is tangent squared. Okay. You would pretty much have to leave it as sine squared over cosine. Well, you could do one other thing, but yes. Note to self, make sure to go back and edit the Miss Henny comment out of the notes. We factored it out, just like over here we factored out the x squared. Do you agree if I multiply this back out, I get the same thing I started with? Same thing here. If I multiply this out, do I get the same thing I started with? Yeah, so if you ever have two that are similar like that, factor them out. There's just a sine squared in each of them, though. So you're just factoring it out. Does this have something in common to both of them? Can we factor out in this one? No. And we better check how far we are. But of course, we'll make it a little shorter than that because we're going to